Let's look at some details about whether everybody agrees on the extremes story in terms of how they are increasing. There are subtle arguments involved, but basically the story is, the science seems pretty clear that extreme events are increasing and potentially becoming more widespread. But to look at a few mechanisms, here is from Rajivan's paper looking at the variability of the extremes themselves instead of just the trends. So here temporal variation of frequency of very heavy rainfall events greater than 150 millimeter per day over central India and its smoothed variation are shown for 1901 to 2004. It just depends on when the papers get published. Smoothed variation of frequency of very heavy rainfall events over central India and SST anomalies over the equatorial Indian Ocean are shown here as well. So this point relates to the multi-decadal mode of monsoon. So in other words, is the recent change that we have been arguing for extreme rainfall events, is it really a trend or is it part of the natural multi-decadal mode of the monsoon? Okay, so this would seem to argue that the extremes have increased and decreased in terms of their frequency over the last century or so. So the trend that we've been arguing for has to be more carefully understood. And it argues that the sea surface temperature warming over the equatorial Indian Ocean is apparently correlated with the rainfall frequency we are looking at here as well. But of course, trend lines always correlate because they are both trends, right? So mechanisms become much more important, and we will touch on that a little bit in terms of where the moisture may be coming from to feed the monsoon extremes over land. Remember that extremes over land need a tremendous amount of water vapor, and that much water vapor is not available on land even when you recycle a lot. So ocean is going to play a critical role in terms of fluxing in the moisture to feed those extreme rain rates of greater than 150 millimeter per day. Thus it becomes intuitive that maybe ocean warming will have something to do with extremes over the land, right? So those are the questions we have to still resolve. Nonetheless, looking at temperature variation of the mean of the highest 4 daily values over central India per season. So you take the whole season and you just look at the temporal variation of the mean. Each season you take the highest 4 daily values over central India again, because that's much more coherent region of monsoon variability. Indian monsoon, peninsular India is kind of not always in phase with the central India, and the northeast India is always out of phase with central India. So even though we average over all these regions for the seasonal monsoon rainfall, they have slightly different variabilities over the season. Okay, so again, this trend line clearly shows that there is a statistically significant trend in mean highest 4 daily values over central India. This is re-emphasizing this message going only from 1950 to 2000, whereas this one went from 1901 to 2004. Okay, so slightly different periods, but it doesn't matter. The other argument is that when these extremes are computed over the central Indian region, the rainfall product at 1 degree by 1 degree resolution is used, which means approximately 100 kilometer by 100 kilometer. And the moving systems that bring these extremes are argued to be counted more than once when you average over such a vast region. Right? If you take rain per day and average over 100 kilometer box, it's possible that the same system that you counted once is again dumping rain at another place. So we'll look at the spatial separation a little bit. But these papers by Subimal Ghosh basically argue that spatial average of rainfall maxima is definitely increasing, but the temporal variance of spatial mean is decreasing. Okay, so is it the spatial variability or is it the temporal variability of the extremes that's increasing? The other paper, he argues that if you look at spatial variability of the seasonal mean rainfall over time, it's decreasing, but the spatial, oops, I chopped off the title there, spatial variability of the extremes rainfall, that is increasing. So this is slightly different point that relates again to where the spatial aggregation of rainfall to infer extremes statistics over central India. But in this book chapter, Goswami argues that this argument of double counting is misplaced, that's not what happens in their method. Okay, so we will leave it there, and I'll come back and add some more points about widespread extremes in the next podcast. But you can see that at any grid point where there is extreme rainfall, people will obviously experience it. Floods happen, especially if it's widespread, then larger regions experience it. But in terms of mechanisms and predictions, it becomes critical to understand whether they are becoming more year by year or they are just becoming spatially more variable, right? So this is very critical. But as long as they remain still tied to the active and break period in terms of their occurrence, then prediction of active and break periods still becomes quite important or useful for anticipating extreme events. I keep saying anticipating because you may predict an active period onset several weeks ahead, but it doesn't mean that within that active period you will be able to predict daily rainfall weeks ahead. You might just say that the break period is ending and active period is coming. Okay, I will leave it there.